and welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Kevin Buckner.
Thank you, Willem. I appreciate that. Welcome to Tech. Excuse me. Okay, so this is part 3. This is an ongoing series, if you will, on cleaning no-clean flux. It's all about paste series, and we talk about cleaning no-clean, but it says no-clean, so I don't have to clean it, right? Well, there's some interesting facts about no-clean that make it cleanable. So when we talk about no clean, let's change our nomenclature for a little while. Instead of saying no clean, let's try and say it as a low residue flux that's actually left on the board. So comparing the no clean to the low residue, let's take a quick trip down memory lane. Now, if you've watched our other 2 parts in this series, you'll see that where the name no clean came up from, it was actually a marketing program, if you will, that was established by a solder paste flux company. Fantastic marketing program to take care of it. But there was also a need for it, okay? Because when we were using Freon TMS and all sorts of other goodies to clean those circuit boards up, we were also destroying the atmosphere. So we were actually causing a problem by making our boards really easy to clean. So there was a need. There was a really, really strong need for something along this lines to actually be developed. So no clean, what's the actual definition of a no clean? What is left behind, right? So we say a no clean flux means that the amount of residue that's left behind is negligible to the point where there's no need for cleaning. Thus, it's in fact just a very, very low residue flux that doesn't require cleaning. Well, if it doesn't require cleaning, then what is actually left behind on the board? Well, trace amounts of non-corrosive materials, some resinous residues on or around the solder joints, and you can see those, and they vary in color from like a transparent to an amber type appearance. The lower the solids content, that's the resins, the gelling agents, and the activators that are in the paste, the lower the residue that's actually left behind on the board. Well, in 50% of the applications that solder and flux and everything is used, that's just fine. When you talk about an iPhone, which has an expectancy of 3 to 4 years, nobody cares if an iPhone dies. You just go to T-Mobile or AT&T or whatever, and you get a new one. If your computer dies, it's an amazing, upsetting experience to yourself, but it's not life dependency. When a B-2 bomber crashes, or when a 737 from Boeing has issues in the air, that's when it becomes a real problem. So anything with something that we call life dependency, which is the high reliability type applications, when they fail, that's when we have a problem. So now we know what it is. How do you clean it? Well, no clean flux is actually not meant to be removed or clean for that matter. It's engineered that way. A true no clean flux will actually repel water. So if you look at that piece of fabric that's sitting over there, when you wear your raincoat and you go out in the rain, and you see those bubbles, the water droplets, if you will, stand up and then sheen run off of the thing, it's repelling water. And that's what no clean, the definition of no clean through a lot of our paste and flux manufacturers is that it repels water. It does not like it. It's hydrophobic. So what are the basics? Let's talk about the basics of cleaning now. So you need a surfactant, you need a solvent, you need something that's going to solubilize that flux, if you will. A surface activity agent, we would consider that. So when dissolved into water, it will interface between the liquid itself and the solid, when the solid being the flux, and then it'll lift that flux into solution, okay? So in picture number 1, you'll see you have your substrate, you have your soil, which is considered the flux, and then you have your detergent, your cleaning agent that submersed in. In picture number 2, you see the solvent or the surfactant is actually coming down and it's going to attach itself to that flux. In picture number 3, you'll see that the solvent, the surfactant, if you will, is actually now starting to lift that flux or solubilize that flux and remove it from your substrate. And then in number 4, you'll see you have a nice clean substrate because you have removed all of the flux, all of the no clean, low residue, off of that board at that point. So what actually goes into making an engineered cleaning agent? And this is the material set that we talk about. So we talk about a solvent. A solvent is the material set that's actually going to do the solubilization, if you will, of the flux. That's the, as we would say, the magic pixie dust that we make in our facility in Nashville, that we actually blend to solubilize the flux. You need activators. Activators are used to induce London and van der Waals dispersive forces. So that's the solubilization without, if you don't have any impingement, whether it be ultrasonics or spray and air, spray under immersion, any of those type of devices, that's what actually gets that solubilization to happen. You need buffers. You have to have buffers in this situation, and you need buffers because we're talking about acid. We're talking about flux, very acidic product. So we use a lot of alkalines to clean and remove that acid from the flux. So you need to stay on that high acidic range so it doesn't become a neutral type product. Becoming neutral is bad because it will go below neutral, go into the acids, and you'll lose the ability to clean. And that's what we're actually trying to do. So we use buffers to stabilize that pH. We use a wetting agent. And a wetting agent takes that surface tension of water where you see that bubble sitting up on top of that. We use glass slides, but you saw it on that piece of fabric. And we have to flatten that bubble out. We have to break down that surface tension to allow the cleaning agent to get underneath BGAs, QFNs, all types of different products. But we use a wetting agent to get it to go underneath there. And then, of course, one of the most important things that we do very well is inhibition agents. And the inhibitors are in there to protect the alloys and other metallic surfaces so we don't get a pitting effect. We get a bright, shiny solder joint, which is very, very important. Do you just need a surfactant chemistry? Well, I wish it was that simple. It's not. We use something called test. And test is broken down into T for time, which is your belt speed. When you're talking about an inline style piece of equipment, you're talking about the belt speed, 0.5 foot per minute up to 2 feet per minute, running through a pre-wash, a wash, a rinse, a final rinse, and then a dry. Impingement time, it's dwell time. How long is it actually in those sections? Becomes very, very important to the cleaning result that you can expect. And then dwell time, how long is it actually staying there? Is it staying in that 12-inch section for 2 minutes, and that's starting to soften? That's in the pre-wash. In the batch style cleaners, we're talking about the wash time, how long you actually in that chamber being exposed to the chemistry itself. We talk about energy. Energy is mechanical energy. That's the forces that are actually hitting the board, which are solubilizing in that flux and getting it off that board, which is very, very important. We need mechanical energy. And then you talk about PSI and flow. They are different things. PSI in an inline style machine, if you have a lower spray and an upper spray, and they're spraying on the board, if the lower is higher than the upper, the board will have a tendency to bounce or rattle as it goes through the machine, and that's not a good thing. So we always set the higher, the upper to a higher PSI rating than we would the lower. So, and then you talk about flow. That's just how much solution is being turned over in the machine itself and being subjected to your boards. We talk about solvency. We talk about the chemistry itself. And do we have a good match in chemistry for the flux that we're trying to move? We hedge our bets a little bit. We work with solder paste companies all the time, and we've tested, 600, 660 different types of paste flux combinations with our solutions to make sure that we know without any impingement type forces, we're going to get solubility, which is very, very important. If we know we have solubility between the flux and the paste itself and the chemistry, we know that we're going to, with a little bit of impingement effort, we're going to actually lift and remove that flux. Concentration, we always talk about concentration. It's very, very important. We don't like to use higher concentrations because chemistry is money. So if we can get you down from, say, 25%, get you down into that 15% or even 13%, we can save money. And that's the most, nobody wants to clean. So if we have to clean, let's try and do it as effectively and cost effective as we can. And temperature is very, very important because most people think that the higher temperature, the better the cleaning. And that's not exactly correct. Sometimes at a slightly lower temperature, we get better cleaning effect. We do try and get above 120, 125 degrees because we have defoaming agents in our products, and those defoaming agents actually become active, if you will, at 125 degrees. Lastly, but not least, and you need to test. That's really what we come down to is validation of your cleaning process. It's very important. And there's what 5 different tests that you can run. One is the IPC standards, if you will, which give you the right direction to go. The second is a visual a standard. Take it under a microscope, take a look at it, and see if you can see any remaining residues that are left. You have the ROSE testing, which is resistivity of solvent extract testing. Only valid as a process control, not a qualification. It measures of sodium equivalency is what it measures to see what's actually sitting on the board. And you will need to buy a piece of equipment for that. Ion chromatography is actually a really cool thing because it identifies specific ionic contaminations that are left on the board. And what that does for you is that can point you into your current process and tell you where you may have a problem somewhere along your lines. And then, of course, SIR, surface insulation resistance testing. You're actually going to run some type of current running through the pattern, the cone pattern, if you will, and see if you can generate some kind of dendritic growth. This one takes a long time. I know there's some companies out now can do a rapid SIR test, which is very good. So that's all I had. I do see a few questions that come up on this topic quite a few times. So I would like to address some of these. Running a no-clean process with chemistry, we would seem to be at the 25 to 30% range, running close to 150 degrees Fahrenheit. Would you say this is accurate? Yeah, I would say it's accurate. The only thing I don't like in that is that 25 to 30% concentration. I would like to see that a lot lower. I would like to see that around that 13 to 15% concentration, but still get you those results that you're looking for. The 150 degrees Fahrenheit is just fine. So lower that concentration depending upon the product you're using, and you should be fine. This one actually is a good one. We recently ran 1,000-piece order and tested cleanliness after the first 50 boards in an alcohol type tester. That would be the zero ion or one of those type machines. The numbers from the test were low. In fact, they showed a pass, so we never washed the entire order. Now the board we tested is gone white, and the customer has refused to bounce the boards. Any ideas? Yeah, you should have cleaned them. What's happened in that situation is the alcohol has actually turned the flux white. So the reason you got a 0 in the test is because all of the low residue, no clean, that's left on the board itself is encapsulated the metal salts. So you won't see any type of ionic bleed coming out. You might see a very small amount, but it'll look clean. It'll pass an equivalence, a sodium equivalency test. It'll pass it because it doesn't show any bleed that's actually come out. So you've kind of fooled yourself in thinking that, yeah, my boards are clean because I got a 0, and yet there's a lot of low residue left on there that needed to be cleaned off. And if you partially clean it and put that board back in there, you'll see that ionic value actually skyrocket. It'll go through the roof because you've unencapsulated some of those metal salts, and that's like a partial cleaning kind of problem. You mentioned a possible test being a visual inspection. We run RF frequency boards. Do you think we can just look at it and determine if they were clean? I wouldn't. RF frequency, the smallest amount of contamination that's left on a board is going to interfere tremendously with your RF type application board. So I wouldn't even take the chance. Visual inspection for an RF board is not a good idea. What I would do is definitely subject them to a clean, if I would, and then I would use other testing protocols to see if I've unencapsulated some of those metal salts or I've left something else. Now, ion chromatography or even SIR testing would be a much better protocol for that. I clean no cleans all the time, but I recently have seen my testing results spike. Any ideas? Yeah, I would say you're probably loaded. Chemistries do get loaded. They have the ability to hold a certain amount of flux, but they do get loaded. And the cleaning efficacy then starts to drop off, if you will. You'll be cleaning at a certain level, and all of a sudden you'll see it starting to decline. That's the cleaning efficacy of the solution itself. It's starting to get loaded, and it's probably time for a good change out. So that being said, I think my time is through. Thank you very much for watching. I really appreciate it. And I'm going to turn it back over to William.
Thank you, Kevin. And thank you guys for tuning in to this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.